Hello mathematicians, we're now going to take a look at integration of the reciprocal function. So if we remember that if we differentiate a log we get the reciprocal function, and further if we differentiate log of a function of x that it equals the derivative over f of x, then what we can see is that if we actually took the integral of both sides, then the integral of 1 on x dx becomes log x plus c, and that the integral of f dashed of x over f of x becomes log of f of x. Now, just in terms of undoing the chain rule, we could have also written this, that the integral of 1 on u du dx, in other words, when we have 1 on the function multiplied by the differential of the function, that will equal log of u. So what we need to do is that we have to remember whenever we encounter a quotient to be integrated, the first thing that we're going to look at is whether or not the top is or can be made into by multiplication or division by a constant, the differential of the bottom. So if that's the case, and it so often will be because of our course, in that case, the result of integration will be a log function. So you need to start searching for these when you have an integral of a quotient. Remember, there is no quotient rule for integration. So if we have a quotient to integrate, we'll either simplify it algebraically or we'll use this concept to be able to integrate it to a log. And that's it. There are only options. So let's have a look at this in practice. So here we have, with our first example, an integral. Is the top, and it's a quotient, is the top the differential of the bottom? Not quite. It would be really nice if we had 4 up the top. So if we decide to put a 4 there, what have we got to do to counteract that? Well, we put a quarter out the front, so that that 1/4 times the 4 effectively cancels each other out. But then this part here becomes the integral of a quotient where the top line is the differential of the bottom. So we know that that's log, so that becomes log of 4x plus 1, so log of the bottom. But it's a quarter of that, and then plus c. Now I'm just going to redo this a little bit more formally. Not that I'm encouraging you to necessarily do this, but it's good to know the formal approach. So the formal approach involves substitution, technique that we've learnt before. So if we let u equal 4x plus 1, so if we let u equal the bottom, then effectively what we're doing is integrating 1 on u. Now, coming back to this, if u equals this, then du dx is 4. So du on 4 is what dx is equal to. So our integral of 1 on 4x plus 1 became 1 on u. Our dx became du on 4. So I'll switch that 4 from under here to out the front. And you can see that it starts to look very familiar. So our integral is 1/4 of log of u plus c. And of course we just then rewrite in terms of the original variable, which was 4x plus 1 plus c. And we had to go back to the original variable because this was an indefinite integral. It didn't have limits, which let us eliminate the need to go back to the original variable. So this is the formal method of doing that integral above. It's obviously slower than thinking about it, but like I said, it's good to have a backup just in case a question becomes really complex. So let's go back to our shortcut method if you like. So if we have this integral, again, quotient, what would the top be if it was a differential of the bottom? Well, it would just be 3. It is 6, so if I write 3 here, what have I got to do? I've got to put a 2 out the front so that I've still got 6 altogether. So this integral then simply becomes 2 log of 3x plus 2 plus c. For this one here, what would we like the top to be? We would like the top to be minus 1. So if I put a minus 1 there, how do I undo that in a sense, I'll put another -1 out the front. So this is minus the log of 3 minus x plus c. Now, just as an interesting little aside, remember that if I have a number out the front, the power rule would let me take that back into there. So this could be written, and it might be written like this either as a target for you to chase or in the answers in the textbook. It could be written as log of 3 minus x to the minus 1, which is log of 1 on 3 minus x plus c. So just have your wits about you for those. These next ones, find primitives, which is, we know, code for find the integral of. These things by first writing them as separate fractions. So when we go to look at this, it's a quotient. The top line as it stands is definitely not the integral of the bottom, but we can use our properties of fractions to say that the integral of this is the same as the integral of x over x plus 1 over x, which is then integral of 1 plus 1 on x dx, which of course is just x plus log x plus c. Just trying to look for one which is a little bit different. I think all of these are going to work the same way. We see a quotient, the top is not the differential of the bottom. We break it up into parts by dividing every term by the bottom, and then just do all the integrals separately. So I'll leave those. So moving on, this one here, find this and then this given this. Now we should be very comfortable with this layout. So this is that if this is the first differential, then this is going to be the primitive of that. So f of x will be x plus 2 log x plus the constant, and we know that f of 1 equals 1. So 1 equals 1 plus 2 log 1 plus c. This is 0. So that tells us that c is 0. Therefore, f of x is x plus 2 log x, and therefore f of 2 is 2 plus 2 log 2, or for what it's worth, 2 plus log of 2 squared, which is 4. Over here, with this one, same as before, we look at this. Here we have a quotient. Is the top line the differential of the bottom? Well, not directly, but it's related to it. So if we look at what the differential of the bottom is, that would be 4x cubed plus 12x. And we can see that the only difference then is that if we had a 4 up the top, then we would now have the top being the differential of the bottom. So if we put the 4 in there, we've got to take a quarter out. So we've got a quarter of the log of the bottom. And likewise, this is x to the half. What is the differential of the bottom? Well, this would be 3 times x to the half. So again, all we need is a 3 here and a third there, and away we go with that integral. So I won't finish that off. So if you have a go at 12c, these ones here. But before you do, think about what is the big idea. What's the overarching emphasis in this particular video in terms of doing the integration of reciprocal functions, and put that at the forefront of your exercises.